WhatsApp number on the chat box. Ibrahim, you can check his WhatsApp number.
Okay. Okay, I can trust you.
Okay,
Well, thank
cool.
you very much.
Awesome.
Wow.
Okay, so
Yes.
I'll do the presentation right about now. So good day, everyone. Good day, good morning, good evening, wherever you are in the world. Welcome to another Power BI section brought to you by UrBizEdge with collaboration of Enterprise DNA. For this session, we're having a special guest by Ibrahim Ogunbiyi. He'll be taking us on the topic how to perform customer segmentation using Python. So as you all know, this session is brought to you by collaboration between Enterprise DNA and UrBizEdge. So for some of you that might be interested in online training in Power BI, so Enterprise DNA has the motto of empowering Power BI users to change the world. They also offer a variety of courses online, which you can also check on the website. And we're also a training company in Lagos, Nigeria. So this is our calendar for some of our upcoming training. So on the 5th of December, we're having financial modeling and DCF valuation. For the 8th of December, we're having business intelligence and dashboard using Microsoft Power BI. Also on the 16th of December, we're having in-depth Excel training, executive dashboard, and business data analysis. And our special guest, Ibrahim. So I'll just give a brief description about Ibrahim. He's an earned data scientist who loves breaking and fixing up data-related stuffs. Taking care of data gives him insight into different portraits. Alongside my data skill, he's also a technical writer. He also blogs in different platforms. So without no further ado, I'll stop sharing my screen. I'll hand over the session to Ibrahim. So Ibrahim, over to you. I'll stop sharing my screen right about now.
Okay. Okay. So thank you very much, David Tayo, for the introduction. So can you almost see my screen and can you hear me audibly?
Loud and clear. Your screen is up. You're on Teams. Okay, here.
Okay. So good day everyone, good morning, good evening, good afternoon, wherever you're joining us from. So today I'll be walking you guys through how to create like a customer segmentation in Python. So this customer segmentation, if you are working in the area of marketing or anywhere data applies to you, anywhere you make use of data, you find out that this customer segmentation of a thing is something that it's core that you must know and it's something that you must perform in your day-to-day activities. Because the reason it allows you to understand your customers. So with that, so that with understanding your customer will now help you portray how you'll be able to like perform recommendations to them. But if you don't understand your customers, you won't know what they need. You won't know what type of customers is this. So like they used to say, there's a saying that you don't do business because you think again, but you do it because of what the data is saying. So like let's just get started into what today's session is all about. So the objectives for today is not something that is really long. So we'll learn about what customer segmentation is. And then, so for today's session, we'll be focusing on a type of customer segmentation because customer segmentation, it has a lot of categories and all that. So one of which is the behavioral segmentation. So that's what we'll be focusing on today. And as well, we'll be learning about the RFM key metric because this key metric is something that you find out that you basically use whenever you want to work with behavioral segmentation. That is whenever you want to understand customer behaviors. So this key metric is something that that you find that it's used in the aspect of marketing, businesses, and all that. And also the last part in which we learn about how to segment our customer using K-means, which is a clustering model in Python. So, so what is customer segmentation? From the word itself, like segmentation. So picking out like the keyword in it, which is segment. That is, you are grouping, different kind of things into different sects. So that's what segmentation basically means. That is, you are grouping entities based on similar properties. So entities could be like you want to group a customer, you want to group a product, you want to group an animal. Like let's say, for instance, you want to group an animal based on their species. So the species there is what is the similar properties. So now, since we've understand what segmentation is all about, so customer segmentation, we can easily just derive and then know what customer segmentation is all about. So customer segmentation means like you are grouping customers based on similar properties. Now, for instance, let's say you want to group your customers based on their age, so that you know, okay, what are the highest age group that we have in our business? Is it that people that are above 70 years old, are they the one that is patronizing us? All those kind of things. So that is what customer segmentation is all about. So basically, you are just grouping customers based on similar properties. So types of customer segmentation, we have like way lots of them. We have demographic, we have behavioral, we have geographic, we have psychographic, we have technographic, and blah, blah, blah. So in your day-to-day activities, like you find out that the top three I listed here is something that you work with basically most time. You work with demographic segmentation, you work with behavioral, and then geographic. So, but today, for our own today's session, we are basically focusing on behavioral segmentation, but I'll be touchlighting on what demographic is all about, so that we just have like an insight into what it's all about. Also, in the past, I've written an article on demographic segmentation, which I'll be sharing maybe after, if there's still time, on as soon as we're done with the session. I will just go through it, skim through it, and then show us what it's all about. So behavioral segmentation is like is a sort of customer segmentation in which you group customers based on how they interact with the company. So it's kind of different, because this behavioral segmentation is one of like the key part of segmentation, customer segmentation, because you want to know how customers interact with your business. So it's more very, very important than the demographic segmentation. So what demographic segmentation means is like you are grouping customers based on their personal interests, like their personal information. Like let's say you are grouping them based on their age, their income. Well, behavioral segmentation is one key thing that you will need mostly in marketing, like in terms of your business, because you want to group so that you'll be able to know, okay, what are the customers like? Which customers? What are your all-take customers? Like customers that patronize you very, very well, customers that are not patronizing you. So with that, behavioral segmentations encapsulate what that is all about, because it helps you group customers based on how they interact or behave to your company. So, when you now want to calculate behavioral segmentation, so there are a lot of ways, there are a lot of metrics. We call it metrics, or like key metrics, in which you can know how customer behave to your business. And this thing, it depends on different kind of domain. One thing, that's why like they say technical skill is a good thing to know, but in the aspect of like domain, you have to be familiar with what needs to be done. Not that you're just saying you want to build like a value count, you're just finding value counts. No, domain knowledge is beyond that. So in terms of building behavioral segmentation, in different kind of domain, there are key metrics that you use. So like let's say now, for instance, let's say you want to know, let's say you want to build a behavioral segmentation for like a website. They have things like bounce rates and all that. But in terms of like, let's say in terms of marketing, you are dealing with products. One of the key metrics that are mostly used is something we call the RFM metrics, which basically means recency, frequency, and monetary value. So what recency means is recency is just a metric that helps you indicate how recent a customer purchased from your company. So this recency metric is something that it differs along different different companies. So like let's say this recency is a metric that can help you know if a customer has churned or not. That is, it's been a long time that you've had from this customer. So with the recency metric, you can know if actually a customer is with you or not. So, and this recency is something that different companies, some company might think, okay, if a customer have not purchased for us for like the last 12 months, that means the customer is not with us again. So that's what recency means. Recency is just like a metric that allows you to know how recent the customer purchased from your company. So the next set of metric that is under the RFM metric is the frequency. So frequency refers to like how frequently a customer purchased from your company. So okay, with this frequency, oh, this is my customer. This is one valuable customer that patronize me every single day, like more often. Wow. So with this metric, you know, because you can see that very like all this metric, it deals with interacting with the business, because recency, it indicates like how recent a customer has purchased, that is the behavior. If the customer has not purchased for a while, then you know, okay, maybe this customer has churned or not. So frequency, basically, it means how frequently a customer has purchased, like how often a customer has purchased from your company. And the last one being the monetary. It determines like how much money a customer has spent on the company. So with this monetary value, you'll be able to like know what are the customers that like we can call them the biggie bagger customers. Customers that are like that they spend lots. If you see them like this, if they are gone from your customer from your business, you know that like you are missing a lot. Customers that can buy, let's say you run a supermarket store, the customers that can buy a million, above million products in a single day. So this monetary metric will help you know all these customers. So the recency RFM, the recency, frequency, and monetary value. So it's a key metric that is basically used in terms of product and marketing. So they use it to what? To know the behavior of the customers to the product. So when you are working with this type of metrics, so there is not like a lot of features that you work with. We only have like about 3 to 4 of them. We have like, let's say, the order date. So you know, okay, with the order dates, you know maybe a customer have purchased recently or not. We have like the invoice and the amount. So that is basically what the recency and the RFM metric is all about. So, you know, this session is not about the theory part, but it's about learning how we can actually build it in Python. So I've built like, you know, a ready-made, what's it called? A ready-made code already. So we just walk through what the thing is all about. So firstly, you know, in terms of, since this is a Python, we are building the customer segmentation based on a Python programming language. So we'll make sure we import the necessary libraries that we want to use. We'll be importing pandas. So pandas will be used for like our data wrangling to load the data, because the data is in the form of an Excel format. So we use it to, you know, pre-process, wrangle our data to clean it and all that. So we have the Seaborn, the Matplotlib, and the Plotly Express. So these are visualizations. These are visualization libraries, and there are libraries that you use for visualization in Python. So we have the K-means, the sklearn K-means cluster. So this library is the one that will assist us in helping us to segment customer. And this K-means is something that it's proved very well to be very, very useful, because people use it a lot. So it's a very, very interesting model. And we have the pre-processing, the standard killer. So this one is just like, we'll get into what this is all about. So it's used to like to pre-process the features so that it will be readily made, be readily available for the K-means. So firstly, I won't load this because it's take a long, it take a time before it will run, because the data is very large. So you know, like once this is just used to get the head of the first 5 elements in the data set. So like I said earlier before, that when you want to work with the RFM metric, so there are not much features that you work with. You only work with like the order dates. You know, the order dates will help you determine the recency, because since like, let's say a customer, let's say now this customer ID like this now, this customer bought, you know, he has made a lot of purchases. So we look at, okay, what's the maximum recent time the customer has bought what it goes from. So that with that one, we're going to like calculate the recent time the customer bought from the company. And another one is like that will make use of is the invoice. So invoice will help us determine, okay, the numbers of, we'll be able to like count the numbers of time the customer have purchased, which will be used for the frequency, and the price, like the amount of the total amount that the customer has been spending to the company. So, what we did here was like a pre-processing features. So what we did here was like in the quantity, there was like there was some, what is it called? Negative values in the quantity. I think maybe this could be as like a result of the data error or data quality, because quantity should always start from like 1 above. So you just find the absolute value. That is, the absolute will be used like to change all the negative quantities. You cannot have like, let's say I want to purchase a good, I cannot have purchased like -5 quantities. So it should be maybe +5. So the absolute will be used to like find the positive value of the quantity. So what we now did here again is like we change, like, I'm waiting for this to run. Once this has run, it will be easy. So I want to like let it run so that we'll be able to interact with it very well. So what we did next is like for the invoice date, beginning from the raw data set, we need to convert it to a datetime so that Python will be able to know that, okay, this feature is a datetime feature. So that's why we make use of the pd.toDatetime. So the essence of this is just to to convert the data, the feature, into a datetime object. So now, so like I said, so the last preprocessing here, which is the total price. So in the data set, the data set has like a price feature. Okay, this is it. It has the price feature and the quantity features. So we need to like know, okay, what's the total price like? So to do that, we just do multiplication, like we multiply the quantity and the price of each. Like let's say now this is a customer, this is a customer ID. The customer bought 15 centimeter of Christmas glass ball and all that. So to get the total price, we just multiply the quantity by the price. So which is something we've done here. So so what we did here now is like you can see from this place, I maxed out on the what's it called? The data set by 2020. So the reason why I did this was like this data set, it contains transactions from 2009 and 2010. So I want to like let us like interact and then know why I created this. And let's say now, for instance, you're an analyst in that company. Let's say this company is an ABC. The name of the company is ABC company. So now the marketing team, they've given you this data set like, okay, our new data analyst, please, this data set contains transaction of customers from 2009 and 2010. And we are already at the end of 2010. So we want to understand the behavior of our customers in the year 2010, that is from January 2010 to December 2010, so that we'll be able to know how we are going to effectively perform our campaign. So we'll know, okay, which customers do we need to send reminders to, that why are they not purchasing. So this is what I did here. So what I did here was like, after I convert this data set, the feature to a datetime object. So I just want to, I maxed out what's it called, the year that the invoice date that contained 2010, so that we'll be able to like, so we want to assume like, let's say the marketing team has given us the tax already. Okay, create like understand the customer segment of the year 2010, want to know the behavior of our customer. So that's why, since we've we've converted the invoice date to datetime, so we can make use of this this attribute here, the .dt here. It will extract, let me say now, for instance, we have df invoice date. So this is the datetime object. So now let's say we want to now extract the year, because we already have 2009 and 2010. So with that, so this is how we are going to extract year. So we make use of this attribute, the .dt.year. It is used to like extract the year. So what we now did here was to max out transactions that are just 2010 only. So which is what we've created here as max df. So now, so moving on to the next thing. The next thing is like in the preprocessing, like when we were doing the preprocessing, we noticed that there are some customers ID, because we want to make use of customer ID. Because it's, so we noticed that like there are some customers that their ID are not found. And this one we cannot this one, if you can, when it comes to customer ID, you cannot say you want to maybe fill the modal value. No, because you want to know for each customer, you want to know the customer so that with that you'll be able to like perform your campaign effectively. So what we did here was to just like drop customers ID that are not present in this data set. So for the max total price without zero, and also one of the issues in the data set was like there's some places whereby the total price is equal to zero. So it could be probably as a result of error. You know, let's say a customer bought two quantity of like, let's say Playcraft Princess Olive, and the total price is saying error. So probably it's an error. So with here we drop out. So this is just used to like remove what's it called? To remove data set that does not have zero total price in that. So now the next thing is like, so the reason for this snapshot is like, let's say now we want to assume like we are in 2010. Like let's say the marketing team just gave me what's it called? The data today, which obviously there will be transactions of today, right? So what I'll be doing is like this snapshot is used to like create another date so that it will look like as maybe I'm analyzing the data tomorrow, so that customers that are there today, they will be inclusive. Like customers that did that did transaction today will be inclusive. So to do that, you just like find, okay, what's the max invoice date. So like the max, so we can see that like the max invoice date, that is the last transaction in this data set, is the 9th of December 2010. So this one is just to use to like create an offset, okay, to make sure that like we are analyzing the data tomorrow so that all these customers will be included. So that is what this snapshot is all about. So now, so this is where the tax really lies on. So let me just like, let me run this so that we'll be able to understand and see. Oh, sorry for that. So the snapshot has been created already. So let me do this like so that we understand how we created this. So now, so this thing is like, we want to get what the thing we are driving out is like, for each customer, we want to know the numbers of times they purchased from the company, the recent time that they purchased, and the total amount that they've spent. So that means what we'll be making use of what? The customer ID. That is, we want to group, we want to like find for each customers, okay, what is the invoice date, the recent invoice date, the numbers of times that they've purchased, and the total price. That means what we'll be grouping with what? With the customer ID. So, so the aggregate, this aggregate method is just used to like, so that we can perform a lot of operations. So now the invoice date, this is what we want to use to get this code here, is something that we will use to get the recent number of days. So recent, like for recency, you make use of days to get like, okay, what's the recent? Is it like the customer purchased last yesterday, or like day before yesterday? So you make use of days in terms of recency. So that is what, and they used to say in terms of recency, less is better. That is how close the number is. That's when that it means that the customer is purchasing. Like let's say the recency value for your particular customer was 2. That means like the customer purchased 2 days ago. But like let's say it was 100. That means like like the customer purchased 100 days ago. So that one is not good. So less is better in terms of frequency, recency. So now what this will do is like, what this snapshot is doing is, so the aggregates here. So to get the invoice, so we want to perform the operation on the invoice day. That is, the invoice day contains like the transaction, the date of transaction. So this snapshot, like I said, the snapshot is like we are using it to perform like as maybe we want to, the snapshot is needed for us to like assume like we are performing the analysis tomorrow, which is, we can say that the max index, max invoice date, that is the max transaction was 9. So the snapshot was 10. That is, we've added a 1 plus day to it, so to make it like 10. So what this is now going to do is like this lambda x snapshot minus max of days. What this will do is like, let me go through it one by one. Lambda x, so snapshot minus x minus max of days. So let's start from here. Let me start from where I liked here. So once we've grouped the data set by the customer ID. So what this will do is this anonymous function will look through the record of this customer. Like, we have like a lot of customer there, right? So group by is just used to look through the list of customer. So it will pick out this x.max, means like it will go to the index date column or feature. It will look at, okay, what is the maximum date, that is the maximum invoice date for that particular customer. And it will look at, okay, let me go to the invoice date, then find the maximum invoice date for this particular, there are like a lot of customers. Okay, so the group by will take like if the first customer, it will look through the transactions that the customer has made and will find the highest the maximum date, which is true. Like, let's say now, for instance, I might be patronizing Jumia for a while, might have patronized in January, December. So I have like my invoice dates transaction on Jumia's record. So what this group I will do is like, it will go to my record, it will pick up my ID, because these are IDs of customers here, right? So it will pick out the ID and look at what is my maximum invoice date. Then, so this snapshot that we've created, we'll now minus it. Like let's take like this now. So let's say now this max date is like the recent transaction of a particular customer. So if I minus the max date from snapshot, I will have like time data like this, that is, it has 1 day, which is true. Like the snapshot that we created was 10. That is on the 10th of December 2020, and the maximum date in the data set was the 9th of 12. So if I minus this invoice date from snapshot, I can see that like, okay, this particular customer purchased 1 day ago. So that's what the invoice date is doing here. So this anonymous function will go into that feature, right? It will now pick out the maximum invoice date for that particular customer, then it will minus it. So this is the value for the snapshot minus max, right? So these days is just used to like access the value itself. You can see that it is 1 year. So if you pass in days, it will bring out the value. So that's what this is all about. So the invoice date. So with this like this, we've gotten our recency. So what this will do at the back end is, we don't need to know how it is working. Just know that, okay, it will group by the customer. Once it is grouping by once the Python is grouping the entire data set by the customer ID, that is, for each customer, it is having all the records of that customer. So it will now go to the invoice date, because we have invoice date feature, right? So let's say now for this particular customer ID, it will look at, okay, what's the maximum date, that is the recent time the customer have purchased. Then it will perform the snapshot to know, okay, maybe the customer purchased 1 day ago or that. So that's what this is all about. So the next one is this one, which we have here, which is the invoice. So the invoice is like, sorry for that. So the invoice is like account, that is this count means like, this invoice, this is an invoice ID right here, the invoice ID for each product the customer purchase. So the invoice, the count there means like, okay, for that customer, since we are grouping by customer ID, okay, just count the numbers of invoice the customer has. That is, so it will know, okay, how many times the customer have purchased. So that is what frequency is all about. So it will just go to the invoice and count the numbers of invoice the customer. Let's say I purchased something from Junior, I'll have an invoice, right? So it will not count, okay, of all the entire transaction I've done at Junior, so like what are the numbers of transaction? So that is what this is all about. So it will count it and then know, okay, for that customer ID, this is the numbers of transaction. So the last one that we want to do, we are saying we are working on 3 metrics, which is recency, frequency, and monetary. So the total price. So what this will do is it will go through all the prices, like the prices for all the goods each customer has purchased, then it will sum out the value. It will sum it out, so we know, okay, how much entirety, since when this customer has joined us, how much has this customer spent to us. So that is what this is all about. All these things are like aggregation. You can decide to make use of what's it called, NumPy, but like in terms of pandas has a shortcut that you can pass in just the letter. Okay, we want to sum, we want to count here. So that is basically what this is all about. So now for us to be able to like get, since we've done this, so we assign it to a variable which we call df result. So we've said that all these things like this now. So this is the result. Okay, we can see now that for this particular customer ID, the invoice dates. So that this thing will not be confusing. So the invoice date actually means recency, because we are calculating recency, we are calculating frequency and the monetary value. So what we just need to do here is like to rename the column, because this is not like the invoice date. We want to know, okay, the recency, which we've done here. All these things, like, firstly, before we can get all these things, we need to pass like the original feature. So that it will not be confusing, we just rename it back to, okay, since we've performed the aggregation that we want to do, so we'll perform it, we change it to, okay, invoice dates will be changed to frequency, the invoice will be changed to frequency, the total price will be changed to monetary value. So this is what this line of code is all about. So we can see now, like for this particular customer ID, we can see that the customer purchased 67 days ago, and the customer has spent the numbers of time the customer has purchased at this company, at this online retail company, is like 41 times. That is, customer have purchased in 41 times, and the total number since when the customer has joined for that particular year. We are working on a particular year, 2010. Okay, since for this particular year, 2010, the customer has spent let's say the currency value is in naira. So the customer has spent 696 naira 90 kobo on since 2010, just within 2010, from January 2010 to December 2010. So this is what we're able to like get. We can see that we have like, these are our customer's ID. For this particular customer, this customer purchased 3 days ago. This customer purchased 3 days ago, the recency. The customer has purchased 71 times, and he has spent 1,323 in total in 2010. So, so once that is done, so we can just perform like an exploratory data analysis. So the reason for performing this exploratory data analysis is to know the distribution of how these our features are. Like, okay, for each customers, what's the distribution for the recency, the frequency, and the monetary value. We can see that like for the recency, we have customers, we can see that this is a rightly skewed distribution. We have customers that have like purchased, look at this customer have purchased like 350 days ago, which is like way too low. But we can see that most of customers have purchased within, this is in the beginning of 10, like within the last 10 days, because we can see that 800 customers, the numbers of customers that have purchased within the last 10 days are like above 800. So that is for that. So then we cannot find the distribution of the frequency as well. So we can see that like frequency, interesting. We see that we have like some customers that have purchased more than 5,000. So we have customers that have purchased more than 5,000. We have customers that have purchased more than 1,000. So this is to know the distribution of the frequency across all the core customer. We'll get into as soon as we go down below, we'll see why there's a need for performing this EDA of a thing. So for the monetary value as well, we can see the distribution. We can see some customers that have like some OPA customers, like rich customers that have purchased more than, that have spent over 300K on the business itself, because these are values for a particular customers. But we can say that most customers, what's this range? Most customers have purchased between 500 and so 500. Most customers have purchased less than 500. So so now, you know, all this EDA that I've been doing, there's a reason for it, because like we said earlier, that this part, that the model that I'll be using to build our clustering model is something we call the K-means model. So now for us to be able to build this K-means model, we want to build it based on these three features: recency, frequency, and monetary value. So just give us a tips into what K-means is all about. So K-means is like an unsupervised model that is used to cluster. What cluster means is another name for segment, that is used to segment characteristics, values under observations under a characteristics. Like let's say you input, you pass in the age of customers. So K-means can help you segment that customers based on what you want to achieve. So now, one thing about K-means is if you look at the name itself, K-means that is the means out of it. This K-means. So it's it means it has mean. So that is what is doing at the back end. We don't need to, one of the beauty of all these things is we don't need to know much implementation of how this thing works. We just have a basic idea. So the K-means is it will find the average of all those data sets to know, okay, for this particular group, what was this age going to belong to? So, and when we know, we've been taught in statistics, if we have a little knowledge of statistics, is that means if you are finding average is always susceptible to what? Is always affected by what? By outliers or something extreme values. So now let's say now, for instance, in this, we can say that the distribution of our recency. Let's say we have the distribution is a normal curve distribution. They used to tell us in normal curve distribution, we find that the mean value and the median, they are always the same thing or close to the same thing. Let's say if you have a distribution of a feature that is a normal distribution, let me just find okay, so this is a normal distribution. So a normal distribution, the mean and the median are always the same thing. But when it comes to skewed data sets, maybe a data set that is skewed to the right, because we can see in this our own case, it is a rightly skewed data set, because we have some extreme values. You can see that we have values that are really extreme. Most of the customers have purchased within 0 to 10 days, but we have customers that have purchased even more than 200 days. So mean, when you are finding average is always affected by outliers, that is extreme values, which is true. Let's see now, for instance, I have 2, 3, 5, and then 100. And now to find their average. So this is 4. So we can see that this because of this extreme value, the average, the mean has been affected. That is the central tendency, it has been affected, which is, so for k-means like that, one of the pre-processing technique that you need to do and in k-means is you need to make sure that your data set is normally distributed. So if the data set is a skewed data set, you need to make sure that it is normally distributed. So, and one of the ways you can make use of to transform the data set is by making use of the logarithm transformation. So logarithm transformation can make sure can help you transform a data set that is skewed. That is, we can see that like this one too, like this now, it's a skewed data set. This one has even way lots outliers because we can see extreme values here. So we need to make sure that it is skewed so that we'll be able to arrive in correct conclusion. Because if we don't, like, if the data is not normally distributed, we might be having incorrect conclusion. So to make sure, because we are making use of k-means, it makes use of average. So we'll make use of we'll make sure that we transform the data set by using by transforming the data set. So there are a lot of ways you can transform the data set. You can make use of the logarithm transformation, sometimes square roots transformation and all that. But the one that is basically used mostly is the logarithm transformation. So now, so that because we want to build the model now using k-means, that is, we have our data sets, we have the customer ID, like we have the recency, frequency, and the monetary value for each customer. So now we want to segment those customers like this now, because we cannot just start saying we want to screen through the entire data set. So we can make use of models that will achieve that. So firstly, we need to transform the data set, like I said, because we are making use of k-means, it will be affected by outliers. So if we transform it, this logarithm transformation will make sure that the data set is a normal distributed data set. So once we can transform it by making use of the logarithm transformation. So so with that now, we have the data set. The data set has been transformed already. So now let's say we want to let's see the distribution of recency. We'll see that now it's in the form of the, what's it called? It might not be really close to normally distributed data sets, but at least we can see, like, because a normal distribution is always in the form of a bell curve. So we can see the arrow, like this is still in the form as compared to this firstly, which has a lot of extreme values. So just remember, when you want to perform k-means, you make sure that your data, if all these at the onset, like from the scratch, if the distribution is normally distributed, there won't be need for us saying we want to transform it using, there won't be need for us to say we want to find the logarithm transformation. But because this data set has a lot of extreme values or outliers, so we need to make sure that firstly, we transform it to be normally distributed. So, and to do that, we make use of the logarithm function. So another thing again, another processing, it's just basically two processing when you want to do k-means. Firstly, you make sure that it is normally distributed, and secondly, you make sure that the data sets are in the same scale. So this first, this df log, what this is all about is like we've made sure that it is normally distributed. So, but they are not in the same scale. So to make sure that they are in the same scale, we make use of an sklearn, a scikit-learn library, which we call standard scalar. So this is why I was saying we'll get to know the reason why we are making use of standard scalar. So standard scalar will make sure that the entire data set, like our df log, they are in the same scale. So once we do that, we can see that, sorry. Okay, so I was having error. I think maybe let me just try and we run all the, so we know. So that would take a while because of the data sets, because of the each. So one thing we just need to know is like when you want to perform k-means, because when you want to perform k-means, the true pre-processing step that you need to know is number one, the assumptions of k-means are like assumptions is that the data set must be what normally distributed. Reason for this is like since it is since we are performing k-means, we said like before that mean when you are finding average or mean is always affected by outliers. So you want to make sure that the data set is normally distributed. So once it is normally distributed, you can now perform k-means. And another thing again is you need to make sure that the data set is in the same scale. So that is what we'll be doing here. So firstly, we make sure that we want to transform, because we see that from here, okay, the thing has gone. So from here, we saw that like the data set itself, like is not normally distributed. We have some outliers. So firstly, we need to transform it. And one of the ways you can use to transform it is using the logarithm transformation. And the next thing is to make sure that it's of the same scale, that is the data sets are of the same scale. So what the scale is meaning like that the mean of the entire data set, it is 1, and the standard deviation is 0. So that is what, sorry, let me move it out. Sorry. Okay, so that has worked like this now. So firstly, we can see that we transform the data set using the logarithm transformation to make sure that it is what it is normally distributed. And the next one is what to make sure that we scale it so that the what standard scaling means is like to make sure that, so standard scaling means like to make sure that the mean is at 0 and the standard deviation is at 1 for like each data, for each feature. So if you calculate the mean for this data set, you find out that it is 0, and for this one as well, it is what it is 1. So that's why we need to like scale the data set. So firstly, you make sure that you transform the data set, and the next one is to make sure that you scale. So now, once that is done, we can now start building our k-means, our clustering model. Now, in a business settings, like mostly in a business settings, let's say, like as a data, we said like we're an analyst, right? And our company came to us, I mean the marketing team, it came to us that, okay, you as the analyst, so we want to, we are already at the end of 2010, so we want to perform like a marketing campaign to our customers based on their behavior. So in the business settings, like the numbers of segments that you want to group the customer into might be already known. Like let's say the marketing team might say, okay, you as the analyst, please just segment our customer into 4 segments for us. Like just segment them into like 4 clusters. That is, segment them into 4 groups. And there are some cases that you don't know the actual group that you want to segment the customer on. So in that case, for like our own case like this now, we don't know the numbers of segments that we want to group our customer on. So you just go through, you play through different kind of segments to know which one will be okay. So now, so what this code is all about is the one that will be used to like go through the numbers of segments that will be okay for the customer segmentation. So firstly, before we go into what this is all about, firstly, this range this range 2 is sorry for that. So what this range 2 is, this is the different type of segments that will be working with, that will be experimenting with. We have like 2, that is, we want to group all the entire customer in 2 segments, 3 segments, 4 segments, 5 segments, 6 segments, 7 segments, 8 segments, 9 segments, and 10 segments. So from this different type of segment that will specify, so we'll now experiment through it to know, okay, which is the optimal numbers of segmentation, numbers of segments that will be used to group our customer. So this is what this first line is used. So this is the model. So what K-means needs is like the K-means model. K-means like the model, it will pass in the numbers of custom clusters, or which is in other words, the numbers of segments that you want to do. So what we did here is like, okay, we look through these numbers of segments that we specify. So we'll now be passing in the value. Okay, for instance, you go from range 2, you pass in the value, then we set the random state to be 42, then we fit the data set, this data set that we scaled, the scale data set, we fit it on the model. Then what this is all about is like we'll calculate the errors. So we created a variable that will contain a list sorry for that. So this cluster error is like a list that will contain the error for each cluster. So what we want to do is we want to experiment through these clusters that we've specified already, 2, 3, and 4. So we want now to the errors from those clusters, we'll assign it to the list. So we'll be able to like select the optimal cluster that we use. So so now to get the errors for each cluster, so that's when we make use of this method, which we call the model inertia. So this one is used to like get the error from each cluster that we've experimented through. So what this code is all about is like, okay, look through all this cluster, fit the model on each cluster, assign the error of that cluster. Let's say now the first loop, the first data that will be taken from the data, the first cluster that will be taken is 2, right? So it will assign the number of cluster to be 2. It will fit it on the data set. The error that it will be gotten from 2 will append it to this cluster. Then we can now plot what's it called? The errors and the clusters to know which one is the optimal value. So now this thing is they call it the EBO method, which is used to like select the optimal number of cluster. So what you do is like you look through the plots and then see where there's like EBO, at least a little bit of EBO that is bent. You know, like our EBO now, we have like something that is bent in it to help us select the optimal cluster. So like if we look at this graph above, we can see that in terms of the EBO is more or less like around this place. It might not really show, but at least we can see that the EBO is kind of at the number 5, the fifth numbers of the 5 number, if we specify the cluster to be 5. So that's when we can say that like there's this form of like EBO. So this is the cluster that we're going to use. So after we fitted this thing here, so we plot it and then find the EBO. This thing they call it the EBO method, which is used to find the optimal cluster. So we can see that the cluster number that is optimal, that looks like an EBO, is the fifth number of cluster. So then we'll now build our final model on the fifth, because since from this data set we said the fifth value is the optimal number of cluster. So we'll build the final model, we pass in the random state. So we fit it on the scale. Don't forget about this, because you are making use of k-means, you have to make sure that the data is normally distributed on the scale. So we fit it. Once we fit it like that, so the model will have what's it called? It will have the so once we've fitted the data, the scale data on the model, so the model will have automatically generate the cluster label, that is the cluster in which, I mean the segments in which the features belong to. So so from here, let's say, let me comment this out. So now the model has already fitted the model already. So let's say to get the clusters in which all the data fall into, so we can see that, let me say we print out the first. So for all the features, like all these observations, like let's say for this customer belongs to the first cluster. So this is what, so now once we've gotten like once we fitted the model, we can now know, okay, for each observation, for each customers, what cluster they belong to. So we'll now go back to the original data set, that is where we calculated the recency, frequency, and monetary. So we'll now, which is this DF result, right? This DF result. So we'll now assign the labels to it. So that we'll be able to know, okay, we'll go to the original features, like the one that we've not transformed and scale. So this is what we are doing here. We'll assign the labels. So it will assign the segments. You know, this 5 cluster means that I want to group the customer into 5 segments. So we have cluster segments 1, segment 2, segment 3, segment 4, segment 5. So it will now add, but the segment is only starting at 0. So we have 0 to 4. We have 0 plus segment 0, segment 1, segment 2, segment 3, segment 4. So this will add, like, it will assign, so we assign like the segments in which the customer belongs to the data set. So this is, which is something we've done here. We've assigned it. So now if you run this now, you can see that, okay, for this particular customer, this customer belongs to the first segment. This customer belongs to the cluster 0 segment. This customer belongs to, so these customers and this customer, they belong to the same segment. So now, once that's done, to be able to like interpret, you know, we've gotten what's it called, the cluster in which each customer belongs to. So now for us to be able to interpret the results, so we'll perform like some aggregation. So now, so that's when the interpreting of the cluster, which is very, very key, because let's say once you are done with the work, you want to explain to the marketing team what you accomplish. So from here, the data, the DF results, which is this, so we'll group the data set based on the cluster label. That is this 1, 0, 1, 4, and 2, blah, blah, blah. We'll group the DF results based on the cluster label. Then we'll find the aggregates. So the reason why I'm using median here is like I said earlier, if you remember from the entire data set, so we said we from the original one, we saw that like recency, the monetary, and the frequency, like they have extreme values. So, and they, like, as a normal rule of thumb, when you want to perform aggregation, let's say you want to perform central tendency on a skew data set, that is data that has extreme value, the type of central tendency that you should make use of is median, because mean is always what affected by outliers. So that's why we are using median here to like aggregate through. So what this is doing is like, okay, group this data set by the cluster label. That is, okay, for like cluster label 1, everything that falls under cluster label 1, find the median of the recency, find the median of the frequency, and find the median of the monetary value. So if you run this now, you can see that this is the result. Okay, for recency, for the cluster label 0, we said that the recency was 7, the frequency was 189, and the monetary value was 3,776. So this is what we can now use to interpret, okay, the cluster label. We said the optimal number of cluster is 5, right? So we want to group the customers into 5, which we've done here. So which is cluster 0, cluster 1, cluster 2, cluster 3, cluster 4. So now if we look at this data set now, we can now interpret what it's talking about. We can see that like this recency for the cluster 0, we have like 7. That is, we have customers that are bought recently, and we have customers that that purchase more often, and customers that spend a lot. So that is what we are seeing here. Like cluster 0 means customers that these are the best customers. Customers that have purchased recently, that purchase frequently, and they spend a lot. So this one is like the cluster 1. We can see that the recency value is 128. That is, we have customers all these customers have purchased like above 100 days ago. That is, it's been a while. So all these customers, it's been long. Like you have a customer that have purchased like 100 days ago, like above 100 days ago. So with all these customers, we can see that like there are customers that are like churned already. So let's say now, according to the rule of, let's say for instance, the policy of this company is that customers that have purchased 100 days ago, like our customers that have churned. So all these ones like this now, we can see that all these customers, they've churned already because it's been a long while that they've purchased. And all these customers are they don't really purchase more frequently. So they don't really purchase more frequently, and they spend way less. You can see that the entire money that they spend on aggregate, on average, for the entire, for 2010 is 368. So for this second cluster, the cluster 2, you can see that all these ones are like active customers because the recency, they only purchased like 17 days ago. They purchase frequently as well. We have 34, at least less frequently. And the monetary value, that is the total number they've spent, is like around 52. So all these ones are like less spender. As well, this cluster 3 is like customers. We can say that the recency value for this one is like 163. All these ones have churned. They don't even purchase more, and they don't spend way less. Even all these ones are like still worse than this one. That is, all these customers, like it's been a long while they've purchased. They only purchased 4 times, and the total number they've spent to the customer is above 100. So we can say that this one's the last one is like all those ones are like less active customers. That is, customers that have purchased 51 days ago, but they've purchased more frequently, and they spend mostly to the business. So all this one, like let's say now, once you are done, once you show this result to your marketing team, okay, they may think, okay, we need to send like a marketing mail to all these customers to tell them they should purchase more and all that. So that is basically how you interpret a cluster label. So once you've created the cluster label, you just find the aggregate. You group by the cluster label, then find the aggregates. If the original data set is not affected by, if the original data set is normally distributed, you can make use of mean. But since it is not normally distributed, you make use of median, so that because mean is affected by outliers. So you cannot visualize the distribution for each cluster label. We can see that cluster label, like I said, less is better. For cluster 0, all these ones are like customers that purchased recently. All these ones are customers that have, which we said here, that we said customer 1 has, or all these customers that have churned. That is customer that it's been a while, a very, very long while. We can see that our customers that are like purchased 300 days ago, or for this one as well, 300 days ago. And we have some customers, this one's too, like they are less active customers. We can see the frequencies too. We can see that customer 0, like we said, because they are the best customers, customers that purchase more frequently. So we can see the distribution. As well, for the monetary value, we can say that, as we said earlier as well, customer 0 are the best customers that purchase, that are like they spent a lot with the company. So you can now visualize and then see the results, which is customer 0. We see that the monetary value, they spend way high, and their frequency is close to like 500. Their recency, this thing is not showing it very well, but they are like, the reason it's not showing is customer 0. We said for recency, less is better. That is, we have customer that purchased 1 day ago is better than customer that purchased 100 days ago. so we can see the aggregate of for each cluster label. So that is the end of the session. So for like I said earlier, this is the customer segmentation that I built. I wrote about, which is based on demographic segmentation. So the slide will be sent along, and the GitHub, if you want to check. So this is the GitHub repo of the session we just performed. So everything will be sent in case you want to check it out and then explore through it. So thank you very, very much. I hope I don't have any.
Awesome. This was actually this well detailed, IB. This very well detailed. Yeah. Okay, so there's a few questions. So basically they're asking for the GitHub repo actually.
Okay, so let me send that.
You can just send to the chat box. You can drop it in the chat box. Okay. I think Benny has dropped the link, your free camp link to the article you wrote about this course you're presenting. Question. Yeah. So can I just drop the link?
Okay, let me drop that now. So this is the GitHub repo today.
Okay, yeah, awesome. So if you have any question for Ibrahim, you can raise your hands up so I can make you a speaker. If you have any question, raise your hands up, let me make you a speaker. Anyone want any question? But just this was okay. I think Oluwaseun has a question, so I'll make Oluwaseun a speaker right about now. So Oluwaseun, you can mute yourself and speak.
All right. Good evening, everyone, and thank you once again. Thank you very much. Yes. So my question is just about how, as analysts, we can empower our collaborators, stakeholders, and the people that we work with real-time insights. So what do I mean by real-time insights? I'm talking about, for example, this data set is like a transactional data set. The instructor spoke about you're looking at, for example, data set of 2010, and then yes, you wanted to use that to guide how the organization might just make decision and move forward in the coming year, or as it were. So like I said earlier, my question is, how can you provide real-time insight? So in a case whereby I need to, in this transactional data set, I need to I don't want to be reactive. I want to be proactive. So I don't want to wait for, yes, it's a combination of two, allowing or waiting for the marketing team to tell me what to do. But I also need to be a source of intelligence to them, to guide them. This is what you should do because this is what the data set is saying. So that's what I meant. I was asking about real-time insights for this particular data set. So I'm just asking for how one can give real-time insights with this particular transactional data sets.
Okay, so let me just comment on that based on my knowledge. So, like there are a lot of tools that can help you achieve different kind of tasks. So for this RFM metric now, for instance, there are a lot of ways in which you can use it to calculate it. We have people that make use of Power BI, right, to create your RFM insight. In terms of Power BI like this now, you are seeing the data, like the visualization in real time. So with that, the marketing team can make use, can make insight, can derive insight and know the way forward or like that. So like for this is more or less like the Python approach is like, let's say you want a more advanced approach, so like creating the RFM metric. So you just, okay, once like, let's say the marketing team give you the data, so you can now perform it. But there are other ways as well. Let's say you want to perform in real time for them. So in case they don't need to come and meet you, okay, you as the analyst, come and do this. So there are ways in which you can do the thing in real time. We have like some ways in which you can do that in Power BI. So I think tell me that if you have like more suggestion on that, you can.
No, I don't know. I don't know. So what? So when you talk about real time, is it like the way the data comes in real time, or so you can easily make you built like a system already? So you want like real time is when the data comes in real time, I can quickly make prediction or quickly make analysis. Is that what you mean, Russia?
Okay, so yes, thank you. So for example, let me just give an example quickly to this, which is instead of me waiting for customers to churn, right? I can just say that, oh, this particular customer that is an active customer has not transacted. Maybe for example, if it's like okay, let me just take the data set that we looked at. So if the person transacts on a daily basis and the person hasn't transacted at least in a day, 24 hours, I feel that for someone that has been very active every day for a period of time and the person
Oh,
didn't transact in 24 hours, I think that's something to just raise an eyebrow. So I won't say to be worried, but at least raise an eyebrow or flag.
okay.
Yeah, yeah. So
Yeah.
okay, I think sorry, I think so for that, like I said earlier, there's a Power BI that can allow you to to do that, and then so so you as the analyst, okay, you want to focus on some certain set of customers. Like let's say in this data set that we work on like this now, we saw that customers, there are some customers like that can purchase close to above 100,000 of goods. So you like that now, tune your system to focus more on those type of customers. So, and I think one of the ways that can allow you to do that is through Power BI, because you have a visualization that will show in real time how all these customers are making the transaction. But making RFM metric in Power BI is beyond this. What we are doing here is the Python approach, but there are ways as well that you can do that in Power BI. Like you segment customers and you show the real time of how customers are making transactions. So I hope that answers your question. And you can search online, and there are a lot of, I've seen people created RFM metric on Power BI before. So I don't,
Okay.
I'm not, does that answer your question? I'm sure.
Oh,
Yes, thank you. I saw something about triggers. Okay.
so you can
That's
set a Power BI. You can do what we call alerts also. So it's just more like a trend. They give like a threshold and everything. But it works on Power BI also. So you can use that also. You can read about alert system. So it's more like a
Okay.
threshold. You can set a threshold. That if someone doesn't meet a particular target, you can get an email that, oh, this customer. It just now it's about you thinking about how you can apply it. That what really matters.
okay. Fair enough. So I work a lot with Streamlit library. So okay, fair enough. So I'm just concerned about not directing people to different platforms and just
Yeah.
but I get the idea. All right, but thank you very much.
You're welcome. So any other question, please raise your hands up. So I'm checking this chat box. No question. There's only, I think everyone is saying awesome section. Only people are asking for repos and everything. Okay, so one more thing. I be right. I told you about the last two questions. Usually ask our special guest. So you're gonna tell us how you started your own, should I call it data science journey or data analytics journey? And also what advice about people just start out in the field of data analytics and data science?
Okay, yeah. So thank you very much for that. So in terms of like actually I studied computer science in school, right? So I've been in tech since inception. So I went through the phase of like web development. I literally tried everything. So I think one of the last thing that I did before I pivoted into data science was I was into IoT. Like I was making home automations, like building C++ and all that. But one thing I noticed then was like, IoT was kind of expensive for me. Like
Expensive.
I was, I wasn't really rich to buy, microcontrollers. Like I was literally wasting money on microcontrollers. So now a friend of mine
Yeah.
now came to me. They were like, "Hey Ibrahim, I know because me, I have this. The vision first thing was like I wanted to go into robotics. I was like, I was to start building robots and stuff like. But I later found out that there's more to it and all that. So a friend of mine now told me, okay, Brian, instead of you saying you want to go into IoT and robotics, why not just try the data science role? And it's something that like I really love mathematics, like in college and statistics or something. So when I started this data science and the data science as a whole, I found out that like I was really finding interest in it. And one thing again I want to say is like apart from like the way that I went to school to learn computer science, I found out that I like all the statistics or everything. I started learning everything from scratch, because one thing that they were teaching us in school then was not related to like what I wanted to do. So I was like taking courses on statistics, like, or other domains like I want to focus on. So for people that want to like get started into data, I have to be sincere. Data is like one interesting you know field to focus on, because like the world now needs a lot of data. Like there are sometimes like when I analyze some data, I used to like find interest, like I find it like inspiring. There's a project I'm actually working on. All of us, I think we are familiar with this Nigeria Bureau of Statistics, right? So I took some data set from there. I'm like, okay, I was analyzing it and then seeing the trends of like how food prices were changing over time. At least having that kind of idea, you won't I'll be more edge than people that are like normal people in the. But I tell them this is what the data is telling me about. So you can see that like I have more edge than people like than normal people. So that is it. Like if you want to get started in data, like there are a ton of courses, and which UrBizEdge as well. I see UrBizEdge over courses like that. So don't just fret about it. Maybe there's a lot of statistics. No. The good thing about it is like you don't need to know like they used to teach us in computer science, we say abstraction. You don't need to know how this game is. It's something I've tried before. I have to be sincere. Like when I was learning machine learning, I was like, I wanted to know how all this logistic regression. I was even writing articles on it then. I found out that I was having a headache, because when you try to deep further, you see that like even the wells still keep going down. You cannot never know everything. So one thing you just need to do is just like know the surface and all that. So if you want to get started in data, I would advise you to, because there are like a lot of job opportunities in data, and it's a very, very interesting field to focus on, because as in, I don't know, when you start like analyzing data, you just see that this thing is interesting. At least you are seeing trends, you are able to like answer questions. So that is basically how like I pivoted into data. So if you want to join data, you are welcome to the field. So yeah. Temina, is there
Oh, sorry. I think mine's out. No question. I think no question. Awesome.
okay.
Awesome. I think I had the same career path. So I started with the old robotic stuff. It was very expensive. Whenever
I
one company
swear.
spoils, you have to buy another one. I just ran away. So
I just
awesome. You do web, HTML, CSS, Bootstrap. Okay.
yeah.
Everyone is saying awesome section. So I think that's all. That's all. So the recording of this session will be made available on our YouTube channel. You can go to YouTube and search for UrBizEdge, UrBizEdge, UrBizEdge.